Welcome to The Explainer. Today we're taking a seriously fascinating look under the hood of modern finance. Have you ever wondered what actually happens when you hit submit on a loan application? Well, we're exploring a brilliant GitHub project created by Cycarin. It's an end-to-end credit risk assessment system, and it literally pulls back the curtain on how artificial intelligence is being used right now to make massive financial decisions. We're going to decode the data, the math, and the technology that sits between a borrower and their money.
It's a scenario almost all of us are pretty familiar with. You need a loan, maybe it's for a house, a car, or to start a business. You hand over your entire financial life story, and then you just wait. But you aren't just waiting on a human being in a suit to review your paperwork anymore. More often than not, you're waiting on an algorithm. So how exactly does a computer decide if you get that loan? What is it actually looking for, and how does it calculate your trustworthiness? Well, that's exactly what this explainer is going to answer.
Here's our roadmap. Number 1, the digital loan officer. 2, inside the applicant data. 3, the machine learning pipeline. 4, measuring model performance. And 5, the interactive dashboard. Let's dive in.
Section 1. The Digital Loan Officer, Meeting the Machine Learning Model.
At its absolute core, Cycarin's project uses logistic regression to do something highly specific. It predicts the probability of a loan default. If you think about the old days of banking, approving a loan often came down to a banker's gut feeling, right? Well, this system completely replaces those human gut feelings with objective statistical estimation. By analyzing the data, it estimates the risk of the applicant, assigns them a concrete credit score, and ultimately outputs a firm recommendation on whether the institution should approve or reject the application. It is pure, data-driven decision-making.
Section 2. Inside the applicant data, the ingredients of a credit score.
We know what the system does, but what exactly is it looking at? The algorithm uses these specific data set features to build a borrower profile. It looks at personal details like age and income, your homeownership status, and your employment length. It evaluates the loan itself too, the intent, amount, interest rate, and that all-important income-to-loan ratio. Crucially, it checks your credit history, length, and whether you have any defaults on file. These are all the ingredients. The model stirs them all together to predict our ultimate target variable, the loan status. Basically, will this specific mix of traits result in a fully paid-off loan or a default?
Section 3. The Machine Learning Pipeline, Building the Brain.
So having the ingredients is one thing, but how does the computer actually learn from them? This is the chronological flow of how raw data transforms into a predictive AI brain. Step 1 involves feature engineering and scaling. That means cleaning the data, handling missing values, and basically putting all the numbers on a level playing field. Step 2 is multicollinearity analysis using VIF. That's really just a fancy way of saying it removes overlapping or redundant information so the model doesn't get confused. Step 3 is absolutely vital, SMOTE for class balancing. In the real world, most people don't default on loans, which means the training data is naturally lopsided. SMOTE synthetically balances the scales so the AI gets a fair, equal look at both good and bad loans during training. Finally, Step 4, logistic regression. This is where the actual algorithm processes this beautifully prepared data and learns how to mathematically weight each factor to predict a default.
Section 4. Measuring model performance. The report card.
We've trained the brain, but before a bank hands over millions of dollars, we really need to see how smart it is. And the story these numbers tell is fascinating. Overall accuracy is solid at 82.11%. But here's the thing about finance. Accuracy isn't everything. Notice the precision at 56.40% compared to a recall of 79.32%. Why the big gap? Well, a high recall means the model is excellent at catching the actual risky loans and flagging them. The trade-off is lower precision, meaning it might flag some perfectly safe borrowers as risky just to be extra cautious. For a bank, missing a massive default is way more costly than accidentally double-checking a safe borrower. The F1 score balances those two metrics out at 65.93%. But the absolute most important metric for evaluating the system's trustworthiness is our final one.
ROCAUC. It stands for Receiver Operating Characteristic Area Under the Curve. I know, it's a huge mouthful, but simply put, it evaluates how well a model can distinguish between two different classes. In our case, safe borrowers versus risky defaults. Cycarin's model achieved an 88.17% ROCAUC score. This is highly impressive. To put that into perspective, it means if you pick one random safe borrower and one random defaulter, there is almost a 90% chance the model will correctly identify which is which. That is the exact kind of reliability financial institutions demand.
Section 5. The Interactive Dashboard,
The final product. Great accuracy on a spreadsheet is nice, but how does a loan officer actually use this on a Tuesday morning? Before we jump into the software itself, we have to talk about this number range, 300 to 850. We all know it, for sure. It's the standard credit score range. Our logistic regression model outputs a raw probability, say a 15% chance of default. But humans don't naturally love dealing in raw probabilities. So this system uses something called a PDO transformation, points to double the odds. It mathematically converts those complex abstract probabilities into this exact, super familiar 300 to 850 scale, making the AI's complex math instantly understandable for both the banker and the consumer sitting across the desk.
All of this is neatly wrapped into a beautiful, user-facing Streamlit dashboard. The user experience is incredibly seamless. A loan officer simply enters the applicant details we discussed earlier: age, income, loan amount. The system instantly runs the model in the background, predicts the probability of default, generates that 300 to 850 credit score, assesses the overall risk level, and clearly outputs a final loan recommendation to either approve or reject. It gives you instant, objective intelligence literally at the push of a button.
What this project ultimately does is take the heavily theoretical world of data science, things like multicollinearity analysis, smote balancing, and logistic regression, and transforms it all into a clear, interactive decision-making tool. It successfully bridges the gap between the data scientist in the back room and the loan officer out on the front lines. It shows how AI isn't just about abstract math. It's about building practical, highly valuable tools that can completely modernize how institutions evaluate financial risk.
So, we've seen the data, we've explored the machine learning pipeline step by step, and we've analyzed the report card. It's a highly sophisticated and remarkably accurate system, but it leaves us with a fascinating real-world question. Knowing exactly how the algorithm works, the mathematical trade-offs it makes, and the precise data it uses, how much do you actually trust AI with your financial future? It's something we all have to consider as these digital loan officers rapidly become the new standard. Thanks for joining me on this explainer, and keep exploring.